In 1947 at Bell Labs, two men decided to collab.
With William Shockley, they worked on electric field effects and aimed to replace vacuum tubes with something more perfect.
On December 16th, they made a huge leap forward. The point contact transistor had just been discovered.
Many years later, as time went by, the types of transistors available began to multiply.
Grown junction, alloy junction, tetrode transistor, surface barrier, drift field, diffusion transistor.
And finally, most commonly prescribed, the epitaxial transistor, which we will now describe.
The first step to making an NPN BJT is to implant an N layer doped with a high concentration of electrons onto the P substrate. Next, an epitaxial layer doped with electrons is built to form the collector, and holes are then diffused into the structure to isolate the NPN BJT. The BJT is then doped with more holes to form the base, and the next step then is to implant an N+ layer to form the emitter. A P+ region is layered onto the base to provide ohmic contact to the base region in case the doping concentration is insufficient, and a dielectric layer with contact etchings is implanted to insulate the BJT. Lastly, metal contacts are placed into these etchings.
Now that you know how the BJT is produced, it's time for you to find out how it's used.
BJTs can be used as an amplifier to get as high a current as you desire.
They're also used in logical gates, which control how computers operate.
The boring part's over, it's time for some fun. Now let's do an experiment to show you how it's done. So this is an AND gate built using two NPN bipolar transistors, and the output will be signaled by this red LED. So as you can see, when input A is logic high and input B is logic low, there is no output, and vice versa when input A is low and input B is high. However, when both input A and B are high, then there will be an output. Lastly, we have an OR gate once again built using the two NPN BJTs. When both inputs are low, there will be no output. However, for all other cases, as you can see, when either input is high or when both inputs are high, there will be an output as represented by the red LED.
Hopefully our breadboard has enlightened you about transistors, logic gates, and what they do.
Now that you know all about BJTs, this module will be such a breeze.
We hope you've understood what we've said, and maybe it's given you more knowledge in your head.
This video has been presented by Ethel and Paul. We hope you've seen that we've given it our all.